So welcome back. Today we will see the part 5 of the sequential circuits lecture. So in this part we will see the flip-flop excitation tables, conversion of flip-flops. So what is the excitation table of the flip-flops? First let us see it is basically the present state next state table with respect to the inputs of a particular flip-flop. So if we see the excitation table of a JK flip-flop, what we have to write? We have to write the truth table in this format. First, in the left column there should be the present state represented by Qn. Then inputs should be there J and K, and then next state Qn plus 1. Okay. Now we have to write all these starting from 000 to 111. Okay. Total, like you can consider Qn, J and K, they are all inputs. Qn, J and K, it is a 3 variable function, and we know with 3 variable function total 8 input combinations are possible, right? So we can write 000, 001, 010, 011, 100, 101, 110, 111, right? Now we already know what will be the next state Qn plus 1 corresponding to this. So when J and K both are 0, present state is 0, what will happen? The next state Qn plus 1, it will be 0. There won't be any change. When J0, K1, Qn 0, what will happen? Next state will also be 0. Next state will also be 0. Okay. Now, because it will follow the J, it will follow, the output will follow J. Now, if J1, K0, present state 0, what will happen? It will follow J. So, Qn plus 1, next state will be 1. If J1, K1, Qn0 flip-flop, what will happen? It will toggle. If my present state is 0, so next state will be 1, right? Again, if J and K both 0, present state is 1, so there won't be any change. Next state will also be 1. If J is 0, K is 1, present state is 1, what will happen? It will follow the J. So, next state will be 0. If J1, K0, present state is 1. So, next state also it will follow J. So, it will be 1. And if J and K both are 1, present state will 1, what will happen? The JK flip-flop will toggle, so output will be 0 because present state was 1, so next state will be 0. Now, we will perform the Carnot map of a 3 variable function. So, here you write Qn and here you write the JK. So, with 3 variables, how many cells we have to form? Total 8 cells. 0, 1, 2, 3, 4, 5, 6, 7. So, now you come, see here in Qn plus 1, see for which input combinations, for which Qn, J and K combinations you are getting Qn plus 1. So 0, 1, 0, that means for 2 you are getting 1, 0, 1, 1, 3 you are getting 1, then 1, 0, 0, 4 you are getting 1, then 1, 1, 0, 6 you are getting 1. So you just write 1 in those particular cells, then you start grouping the ones. Okay, so here we can group the ones, this one and this one we can group. So for this one, what we will get, which one is not changing? Here it is Qn bar and it is J, right? And for these two ones, what will happen? Qn and which one is not changing? K bar. So this is called the characteristic equation of the JK flip-flop, which we are getting Qn plus 1 equals to Qn bar J plus Qn K bar. Okay. Similarly, for SR flip-flop, we have to write the present state next state table in the same format, 000 to 110. Okay. Because if I write how many combinations are here? 0, 0, 0, 0, 0, 1, 2, then 2. If I write 3, why did we skip 3? Because if we had written 3, that means 0, 1, 1. So when S and R both are 1, we have seen that condition is a forbidden state in SR flip-flop. So that can be skipped. Then this is 4, this is 5, 1, 1, 0. Again, if you write 1, S is becoming 1, R is becoming 1, right? So that condition is forbidden. We can skip that condition. Now, this, if S0, R0, Qn0, present state 0, next state will be 0. If S0, R1, present state 0, next state will follow S. If present state 0, S0, S1 and R0, next state will simply follow S. If 0, 0, present state 1, next state will be 1 because no change will be there. 0, 1 means what will happen? It will follow the S input. 1, 0 means what will happen? If present state is 1, it will simply follow, next state will simply follow the S input. Okay. Now you see the Qn plus 1 where you are getting the 1. For which input combinations you are getting 1? For 2 you are getting 1. For 4 you are getting 1. For 6 you are getting 1, right? For 2, 4, 6 you are getting 1, and for 3 and 7 where 3 means 0, 1, 1 and 7 means triple 1. So those conditions we can write as don't cares. Now you start forming grouping up the ones with the don't cares, and the characteristic equation you are getting over here is S plus Q n bar. Okay. Now let's move on to the excitation table of the T flip-flop or toggle flip-flop. So in T flip-flop or toggle flip-flop, what happens? Whenever my T input is 1, so then only the flip-flop will toggle. So you can see here T flip-flop we can have only one input, right? So here you can consider these Q1 and T both inputs. So with two inputs we can have four input combinations 0 0 0 1 1 0 1 1. So when T is 0, present state is 0, next state will be 0, no change. When T is 1, then only flip flop will toggle. So present state was 0, next state will become 1. If T is 0, again no change will be there, present state 0, same, next state will also be same. Now if T is 1, present state is 1, then next flip-flop will toggle, next state will become 0 because present state is 1. Now you form a this Carnot map for a two variable function. So we'll have four cells 0, 1, 2, 3. So Qn plus 1 is 1 for which combinations? 1 and 2. So in those particular cells you just write 1 since grouping is not possible over here. So this is my characteristic equation. For this one it is Qn T bar, and for this one it is Qn bar T. Okay. So this is the characteristic equation of the T flip-flop. Now if we consider the excitation table for G flip-flop also have the one single input. So Qn, if you consider another input, so with two input, four combinations are possible 0 0 0 1 1 0 and 1 1. So in D flip-flop, what happens? The whenever the D is 1, then only the flip-flop output it follows the D input, right? When D is 0, what happens? When D is 0, what happens? If present state is 0, next state will be 0. When D is 1, if present state is 0, next state will follow the input D. If D is 0, then if present state is 1, the next state will be 0. It will simply follow the Qn plus 1. Next state will simply follow the input D. Okay. Next state will simply follow the input D. Here you can see 0 1 0 1. Next state will also be 0 1 0 1. So if you check only Qn plus 1, you are getting 1 for 1 and 3. So write 1 and 3, and characteristic equation is D. Okay. Now we will come how we can convert one type of flip-flop to another type of flip-flop. Okay, if I want to convert the SR flip-flop to JK flip-flop, what will happen? So here the external inputs are already available to the SR flip-flop, and it will be J and K. Okay, and S and R, they are the outputs. These J and K are the external inputs that are already available, right? And these S and R, they are the outputs of the combinational circuit, which are also actual out inputs to your SR flip-flop. Okay, now we write the truth table with this JK, Qn plus 1, Qn present state, and Qn plus 1 next state, S and R. Okay, so this next state Qn plus 1, it is obtained when the particular J and K inputs are applied. Okay, so Qn denotes the state of the flip-flop before the application of the inputs, and Qn plus 1, it refers to the state of the flip-flop that is available after the application of the inputs. Okay, J, K and Qn can have 8 combinations. We know with 3 variables, 3 input variables, we can have 8 combinations. So for each combinations of J, K and Qn, so we need to find out the corresponding Qn plus 1. Okay, that is, we need to determine to which next state the JK flip-flop will go from the present state Qn. Okay, if the present input, when the present input J and K are applied. Now you have to complete the table by writing the values of the S and R required to reach to this Qn plus 1 state or next state from the corresponding Qn. That is, we have to write what values of S and R are required to change the state of the flip-flop from Qn to Qn plus 1. Got it? Now we shall proceed. So with 3 input variables, first we can have 8 combinations 0 0 0 to 1 1 1. So when same process we have to analyze, when J Qn 0, J0, K0, there won't be any change. Okay, so here also J0, K0, no change. Whatever be the present state, next state will be same. Now when J0, K1 present state 0, next state will follow J. 0 1 present state 1, next state will follow J. 1 0 present state 0, next state will follow J. 1 0 present state 1, next state will follow J. 1 1, now your flip-flop will toggle. Present state is 0, so next state will become 1. Now present state is 0, sorry 1, next state will become 0. Okay, so now what we have to do? Now we have to check that for what values of these S and R are required to change this the state of the flip-flop from Qn to Qn plus 1. Alright. Now, if you can see over here, so what values of S and R we need to apply to change the state of this flip-flop from this Qn to Qn plus 1. Okay, so accordingly we have to fill it. Okay, so when S 0 R don't care, so if present state is 0, Qn plus 1 also is 0. If we put S don't care R 0, if present state 1, Qn plus 1 also be 0. Likewise, we have to fill the S and R inputs. Okay, now we need to now see for the S column, for which input combinations of J, K and Qn S is don't care and 1. So with 3 input variables we can have 8 number of cells, right? So we can fill in the cells the 1 and don't care. We have don't care in 1. So 1, we have don't care in the cell number 1. We have don't 1 in the cell number 4. We have don't care in the cell number 5. We have 1 in the cell number 6. So we need to start grouping. So the characteristic equation or the K-map for this S will be JQN bar. Okay, next you see the R column. For which input combinations of J, K and Qn, your R is don't care and 1. So accordingly you start grouping. So the K-map for R you are getting KQn. Now you just write over here a JK flip-flop. You draw here, put the AND gates here, and this is your SR latch, right? So S means S will get, and this is your QN and this is your QN bar. So S means J QN bar, just give a feedback in the J input, and R means what? K into QN. So this is the final equation. This is called the logic diagram. So this is how you are converting the SR flip-flop to the JK flip-flop. Okay. Now, there is a mistake. This is basically the JK flip-flop, conversion of the JK flip-flop to the SR flip-flop. First, we have seen the conversion of SR flip-flop to JK flip-flop. So now we shall see the conversion of JK flip-flop to the SR flip-flop. Okay. So here the external inputs, these are already available at the J and the K flip-flop. Okay. And that will be S and R. J and K are the outputs of the combinational circuits, which are also the actual inputs of your J and the K flip-flop. So we have to get the values of J and K in terms of S, R and Qn. Okay. Thus, we have to write a table using S, R, Qn, Qn plus 1, J and K. The external inputs S and R, and the present state output, this Qn. Okay, it can make 8 possible combinations. Okay, so for each combinations we have to find the corresponding next state Qn plus 1, and in the SR flip-flop we know that the combination S1 and R1 is not permitted, so we can the corresponding output is invalid. Okay, so that means the corresponding J and K will be don't care. So we have to complete the table by writing the values of J and K required to get each Qn plus 1 from the corresponding Qn. Okay. So let's see. Here you can see we have avoided, if starting from 0, 0, 0, 0, 0, this is 0, 1, 2, 3, 4, 5. So 6 and 7 are avoided because 6 means 110, S1, K1, that is not permitted, and 7 means 111, that is also not permitted. So when S0, R0, Qn 0, next state won't change. S0, R0, Qn 1, next state also won't change. Whatever is the present state you will get as the next state. 0, 1, 0. And so if the present state is 0, next state it will follow, simply follow your S. Okay, next state will be S. And 0, 1 present state is 1, next state will follow S. 1, 0, if present state 0, next state will follow S. 1, 0 present state is 1, next state will follow J. Now, so you have to put the input combinations of J and K such that from Qn you will get these state values of Qn plus 1. So these are the when J0, K don't care. If Qn 0, Qn plus 1 will be 0. If J don't care, K0, Qn 1, Qn plus 1 will be 1. If J 0, K don't care, then if Qn 0, next state will follow J, so it will be Qn plus 1 1 will be 0. If J don't care K1, what will happen? Present state, if it is 1, next state will be 0. Okay. Now, if J1, K don't care, what will happen? If present state 0, then next state it will follow J. If J don't care and K 0, what will happen? If present state is 1, next state will be 1. Okay. Now we have to see the J column and K column for which input combinations of S, R and Qn we are getting 1 and don't care over here, and for K column also we have to check for which input combinations of S, R and Qn we are getting the don't care and the 1. Okay, so similarly for 3 input variable we have to make a Carnot map with 8 cells each. So here you can group all these 1 and don't care together. Here you are getting J equals to S and here you are getting KR. So if you draw the logic diagram, you just give the S input to J and R input to K. Okay. Now this is how you are converting the JK flip-flop to the SR flip-flop. Okay. Now we shall convert the SR flip-flop to the D flip-flop. So if we want to convert the SR flip-flop to D flip-flop, what we have to do? Here you can see the SR flip-flop is available and we want the operation of the D flip-flop from it. Okay, so D is the external input. D is the external input and the outputs of the combinational circuits are the input to the available SR flip-flop. Okay, so we need to express the inputs of the existing flip-flop S and R in terms of the external input D and the present state Qn. Okay, so here is the conversion table, the K maps for S and R in terms of D and Qn. Alright, so here you can consider these D input and the present state are the 2 inputs. So with 2 inputs we can have 4 variables, right? So 0, 0, 0, 1, 1, 0, 1, 1, 1. So the next state, the output of the D flip-flop will simply follow the D input. So next state will simply follow whatever the inputs are applied to the D. So we need to set the values of S and R similar to the previous cases in such a way when the present state will switch to the Qn plus 1. So if we put S0 and R don't care and present state is 0, then only next state we get the 0. Okay, then if present state is if S0 and R1, if Qn 1, next state will, what will happen? It will simply follow S. So Qn plus 1 will be 0. If this is 1, this is 0, then if present state is 0, next state will simply follow the S, and if it is don't care and 0, present state 1 means next state will also be 1. Okay, so now you check for which input combinations of D and Qn you are getting the 1 and don't care value under S column and R column. So you make the Carnot maps. So you are getting S equals to D, R equals to D bar. You make the SR flip-flop logic diagram. SR, this is the clock signal, Qn bar. So S equals to D and R equals to D bar. So we need to simply put an inverter over here, right? Now we shall see the conversion of the D flip-flop to the SR flip-flop. Okay, so here D flip-flop is available and we want SR flip-flop operation from it. So S and R are the external inputs and D is the actual input to the existing flip-flop. Okay, so what will happen? S, R and Qn, it will make the 8 possible combinations, and we know S and R, if both are 1, it makes an invalid condition. So the corresponding entries for these Qn plus 1 and D are don't cares. Okay, so we need to express these D in terms of S, R and Qn. Okay, so with 3 inputs SR and Qn, we can have 8 possible combinations, right? But Similar to the previous cases, 110 and 111, these combinations can be avoided because these are forbidden conditions. So when S0 R0, next state will be, present state is 0, there won't be any change. In these two cases, there won't be any change to the present next state. Okay, it will simply follow the present state. For these two conditions, the next state will simply follow the S input. Okay, and for these two conditions, next state will simply follow the S input. And when my D is 0, you can see D is 0. You see the D input combinations. We need to put the D input combinations in such a way with respect to this present state so that I get the next state like this. So in D input, if these are my D inputs, so what will happen? Next state will simply follow the D input, right? So you see for which input combinations of S, R and Q, N, you are getting 1 under D. Okay, so you make a Carnot map with 3 input variables. So we will have the 8 cells. You make the grouping with ones and don't cares, and you are getting the Carnot map for D as S plus R bar Qn. Okay, so you make this. We are making we are converting the D flip flop to SR flip flop, right? So just this is the D input, this is Qn output, Qn bar output. Okay, so D means S plus this is R bar Qn. R bar and Qn will be ANDed here, and that output will be ORed here with the S input, and that will go to the D input. Okay, so next we will see the conversion of the JK flip flop to the T flip flop. Okay, so here JK flip flop is available and we want the T flip flop operation from it. Okay, so T is the external input and J and K are the actual inputs to the existing flip flop, and this Qn make the this T and Qn, it can make 4 combinations. Okay, so with 2 input variables we can have 4 combinations, and if we know whenever the T is 1, flip flop will toggle. So in this case, when T is 0, next state won't be changed. Whatever is the present state, next state will be same, and whenever T is 1, so next state will be toggling. If present state is 0, it will become 1. If present state is 1, it will become 0. Okay, now we have to put the J and K input combinations in such a way so that we get the transitions from Qn to Qn plus 1 exactly like this. Okay, so now you see for the J column, for which input combinations of T and Qn you are getting 1 and don't care. Similarly, for which input combinations of T and Qn you are getting the don't care and 1 for K. So you make the Carnot map for J and K, you are getting both as T. So you just both the T input is common to both the J and K, right? Now if we want to convert this JK flip flop to the D flip flop, what will happen? So here JK flip flop is available and we want the D flip flop operation from it. Okay, so D is the external input and J and K are the actual inputs to the existing flip flop, right? So D and Qn, it will make the 4 combinations, and we need to express the inputs of the existing flip flop J and K in terms of the external input D and the present state Qn. So in we know that this for D flip flop, the next state will simply follow whatever is the present state when you apply the clock signal. Now When j is 0, don't care, then only qn plus 1 next state will be 0. When present state is 0, likewise you satisfy, you just we have to fill the j and k inputs in such a way so that this table is satisfied. Okay, now we need to see the input combinations of j and k. For which input combinations of d and qn we are getting 1 and don't care combinations, just we need to draw the k maps. So now you put the, we are converting the jk flip flop to the d flip flop, right? So j and k are the two inputs, qn and qn bar are the outputs. So here j equals to d, k equals to d bar. So we need to simply put an inverter over here. Okay, so now we will discuss the conversion of the d flip flop to the jk flip flop. So here d flip flop is available and jk flip flop operates from it. Okay, so j and k are the external inputs, that is the input to the combinational circuit, and d is the in actual input to the existing flip-flop. Okay, so j, k and qn, three variables will make 8 combinations. We need to express the input of the existing flip-flop d in terms of the external inputs j, k and the present state qn. Okay, so we will have total 8 combinations starting from 0, 0, 0 to 1, 1, 1, and these if we know whenever in this condition what will happen, no change in the next state. In this condition, next state will simply follow the j input, and in this condition next state will also simply follow the j input, and in this condition my next state will toggle with respect to whatever is applied to the present state. Now you put the what will my input combination, input combination will be the what output will simply follow the d input, right? If you see here, these d and qn plus 1 are same. Now you check the d column for which input combinations of j, k and qn d is 1. So we need to it is a free variable function, so 8 cells will be there. So where is 1? 0, 0, 1, that means 1 is 1, then 1, 0, 0, 4 is 1, 5 is 1, 6 is 1. Okay, so my cardinal map for d will be j qn bar plus k bar qn. So we are converting d flip flop to the jk flip flop. So here this is the d input, this is the clock signal, this is qn output, qn bar output. D equals to j qn bar. So this is my AND gate where I am giving j input, and we have to take this qn bar signal feedback to this another input of this AND gate, and this is k bar. We have to use a NOT gate or inverter here. K bar into this is my k bar, and this is another input of this AND gate will be qn. So these we have to make an OR, and this OR is applied as a input to the D.